For today, we're going to discuss the conic sections. So at the end of the lesson, the student should be able to apply basic concepts and properties of the conic sections in solving application problems. A conic section, or simply a conic, is the path of a point which moves so that its distance from a fixed point is constant ratio to the distance from a fixed line. So we are mentioning here two quantities or two fixed location. One is the fixed point, which we would be calling the focus, and the fixed line, which we would be calling the directrix. Again, so we have that two fixed locations. Fixed point is the focus, and fixed line, directrix. The plural for focus would be foci, while the plural for the directrix would be directrices. The eccentricity is the constant ratio given by E equal to C over A. So we will be discussing later what is C and what is A, but this is a constant ratio that would determine what type of conic would that be. Depending on the value of the eccentricity E, the conic sections are defined as follows. If the eccentricity is 1, the conic section is a parabola. If the eccentricity is less than 1, the conic section is an ellipse. If the eccentricity is greater than 1, the conic section is a hyperbola. So this is a parabola, the shaded region. So take note that this is a conic section, meaning it is a section when we have a cutting plane at an angle parallel to the axis of the cone, or sorry, parallel to the transverse axis of the cone. We would also be having another conic section, which is the ellipse. The ellipse would be having a cutting plane with an angle relatively smaller than the axis for the parabola. While if we have a vertical plane, so we would be having a hyperbola.